good afternoon, good evening, wherever you may be watching this from. This is Cornelius Lubinda with another video. Alright, so now we are looking at differentiation, the notation, and then we still have these three questions. I'm going to introduce something now. Find the derivative of with respect to x. So find the derivative with respect to x of, so WRT means with respect to x of those. Okay, so this is a video talking about notation. When you're asked about the rate of change, or you are asked to find the derivative, or you are asked to find the gradient function, or you are asked to find the dy dx, this is all the same. They all represent one thing. You are finding the derivative, it's the same as saying you are finding the gradient function, the same as saying you are finding the dy dx, the same as saying that you are finding the rate of change. All these things are the same. So here I've said find the derivative with respect to x of this. Now it means we are going to this letter D means differentiate a particular function represented by y. So dy differentiates y, dx means with respect to x, differentiate with respect to x. This is the notation. This is what we do, dy dx. As you saw in the previous video, we were using the first principle. Now if you find the derivative using the first principle, it is a lengthy process. It is not something that you can do in 1 minute. Of course you can try to do it, but you will do it with many mistakes. So finding the derivative using dy dx is very faster, or finding the gradient function using dy dx is way faster, or finding the rate of change using dy dx, it is way faster. So I'm going to show you how to find dy dx of a function. So in this video we are going to answer question A, B and C in one video, and it's going to be way faster. So question A, y is equal to 3x squared, and you want us to find the derivative of that with respect to x. We always say dy dx is equal to this number here, 2, you multiply by 3. So this number 2, you multiply by 3. 2 times 3, then x, you maintain the x, the power there is 2, you also maintain the power, then you subtract 1. So 2, you multiply by 3, maintain the x and the power, then you subtract 1. When you differentiate this, you are going to have dy dx is equal to 2 times 3, 6, x. 2 minus 1 is 1. Now anything the power 1 we don't write, because we know here there's a power 1. So the answer is 6x. And in the previous video, previous videos, using the first principle, we found 6x. Alright. Then we have our B. Y is equal to x cubed minus x squared plus 1. Your dy dx is equal to 3. You multiply by the number in front, which is just 1, so I won't write the 1, I'll just say 3 times x, maintain the x, then the power is, because there's an invisible 1 there, okay. So the 3 minus 1, then you minus the 2, you multiply by the x. There's a power 2 there, we minus 1, then you plus 1 right there. Now, in calculus, what you need to know, that if you have a constant, for example, in this case, the constant is the number 1. There is an invisible x there that you cannot see, like that. Now, what you need to know about this invisible x, it is raised to the power 0. That is why we don't write it. Anything to the power 0 is simply 1. So even if it was 5, there would be an invisible x raised to the power 0. So it would have been plus 5. We would have just written plus 5. Now in this case, it is plus 1 x to the power 0. Let's now go ahead and simplify. This would be 3x. Okay, 3 times 1 is 1. Then the x is the power of x rather is 3 minus 1 is 2. You minus 2x. 2 minus 1 is 1. Then here, the 0 will multiply the 1 there. It will give you plus 0 multiplied by x to the power 0 minus 1. So whatever you do here, we are multiplying everything here by 0. So it is not important what's happened. Don't even overthink. It is not important. So what I mean, dy dx, okay, of 1 is equal to 0. Dy dx of so if you're finding dy dx of 5, it is equal to 0. The derivative of a constant, any constant, it is 0 because of what's happening here. The 0 will be multiplied by the 1, and then the 0 multiply everything. Even if you're saying this might become x to the power negative 1, 0 times x to the power negative 1 is just 0. So your final answer would be dy dx is equal to 3x squared minus 2x. And this is what we found in the prior video using the first principle. For c, y is equal to square root of x plus 4x squared. Then if we find the dy dx, Alright. So, when you're finding the derivative in the, of a set, this is a set, right? Now this particular set is a square root. We need to know our algebra. There is this power, this rule. There is a, the power m over n is equal to root of n, a, you multiply it by m. What have I done there? So what I've done here is I'm saying that the denominator of a fraction or index is the root. Then the numerator, whatever is there, we multiply by the numerator. So this square root of x is the same as saying x to the power 1 over 2. It will be equal to x like that. Then there is a 1 there. The 1, we do that. Now anything to the power 1, we just write x like that. We don't write the power 1, we just write square root x. Why am I telling you all these things? In writing the square root, we don't write this number 2 here. But if it was the cube root, maybe if it was 3 here, we would have written 3. And this would have been the cube root of x. But for square root, it is special. We don't write the number 2. Okay. Alright, hope that's clear. So it means that before we even find the derivative, let's write it in this form. Just for people to understand, it is x to the power half plus 4x squared. Then if we find the dy dx, therefore dy dx would be equal to 1/2 x to the power half minus 1, okay, plus, so you need to get used When we're differentiating, we don't write like this. We skip this step and we just write this answer. So when we're differentiating, to define dy dx of this, you just do this. You just say dy dx is equal to 6x. Writing what I've showed you is not necessary. It is not even working. It is just for you not to get confused. So here I won't write 2 times 4. I'll just write 8x. That's all. Because it is the power 2 minus 1, just 8x. I'll write it like that. Alright, then if we take this up here, it will mean that we are saying is equal to 1/2 x to the power negative half. Because we are saying 1/2 minus 1 is negative half plus 8x. Therefore, our dy dx is equal to, since the negative index, to make it positive, it should go down on the numerator, on the denominator, sorry, to 2. So it will be 1, you divide by 2. Then, I said half is the same as square root. So since it has gone down, it's a positive, okay? 2x plus 8. And that's your final answer. When we use the first principle, we did not find these answers. Okay? When we use the first principle, we found these answers. But we did not find these answers this quickly. This is why we use dy dx. We don't use the first principle. Only when you're taught. So for additional mathematics, you need to know how to find the derivative using the first principle. But so that when in an event where I ask find the derivative using the first principle, you won't be stuck. But when they ask you to find the derivative, use dy dx and not the first principle, because you will waste time. Thank you so much for watching this video. This has been Cornelius Winda, and bye bye.